Let's take a look at this question. Doris had 4 similar containers made of 4 different materials A, B, C, and D. She put an equal amount of ice cubes into each container. Then Doris placed all the containers into a basin of hot water as shown below. We have the basin, we have the 4 containers made from material A, B, C, and D. We have the hot water and we have the ice cubes. Okay, everything is the same except for the materials. Doris recorded the time taken for the ice cubes to melt completely in each container in the graph. Okay, we have A, B, C, D. Okay. Before we take a look at the questions, I want to look at the information that's given to us in detail. Now we are looking at the 4 different materials, so we are testing on these 4 different materials. Okay, we are testing on these 4 different materials. Now then they have ice cubes and then they have the time taken for it to melt completely. Now then you have to think, what property are they testing? Okay. Now you have to look at the graph. Okay. If something take very long to melt, something quickly melt, what is it testing? Okay, it's actually testing whether the material is it a good or bad conductor. Okay, usually we are not interested in the middle information. So A and D, those are in the middle. I'm not interested. I'm only interested in B and C. Okay, for B, it took only a few minutes to melt. And for C, it took quite a number of minutes to melt. You can see the number of minutes is higher. So when you take a very short time to melt, does it mean that it's a good conductor or bad conductor? Okay, now if it takes a very short time to melt, it means that the heat gain from the hot water or the heat transfer from the hot water to the ice cube is very fast. Okay, if it is very fast, it melts quickly. Therefore, if you can let it travel very fast, it means that it is a good conductor. Okay, for C, the heat gain is very slow. The ice cube gain heat very slowly from the hot water. So this one must be a bad conductor because heat cannot move quickly. So this is a bad conductor. Okay, this is how we read the graph. From the results above, which material is the most suitable for making the handle of a cooking pot? Now we need to list from the results above. We are going to list down the material. We're going to list down the most suitable material. We are just listing down. It's only 1 mark. Okay, the explaining part is on B. It's at question B, at part B. Okay, so this one I'm going to list. Just as I explained just now, so this one should be material C. Okay, explain your answer in A. Now, this part, we have to refer to the experiment. Okay, you have to write almost exactly what is in the question so as to explain clearly. Okay, why did you arrive at material C? Okay, as the answer. Okay, I'm just going to write down the answer as the time taken for the ice cubes to melt completely in container made of material C is the longest. Okay, the okay, then you have to explain it is the worst conductor of heat in this experiment. Okay, so these are the 2 marks. First, you have to state, okay, the time taken is the longest. Then you have to also state that it is the worst conductor so that the examiner knows, okay, you are choosing the worst conductor to make the handle for the cooking pot. Okay, which material is the most suitable for making a container that keep drinks cold for a very long time? Now we are going to keep drinks cold for a very long time. Are we going to have a good conductor or bad conductor? Again, we are going to choose B or C. Okay, if it is a good conductor, that means the drinks will gain heat quickly and it will get hot quickly. Do you want that? No, you want to keep it cold for a very long time, so it should gain heat very slowly. So it must be a bad conductor. So again, this one is material C. Okay, this is a very common question for heat. Okay, they always like to give you experiments, then ask you to apply. Okay, what material are you going to choose if you make this and make that? Okay, think in terms of good and bad conductors. Then you should be around there. Okay, around the answer. Thank you.